Hello, my dear students. I will take one more example to calculate changes in the length, diameter, and volume of a vessel when it is subjected to internal pressure. Okay, so let us take this example. A cylindrical vessel whose ends are closed by means of rigid flange plate is made of steel plate 3 mm thick. The internal length and diameter of vessel are 50 cm and 25 cm respectively. Determine the longitudinal and circumferential stresses in the cylindrical shell due to an internal fluid pressure of 3 meganewton per meter square. Also calculate increase in the length, diameter and volume of the vessel. Tip modulus of elasticity is equal to 200 giganewton per meter square and Poisson's ratio is equal to 0.25. Okay, here this is the given problem. It is asked to find the longitudinal and circumferential stresses and also changes in the length, diameter and volume. Okay, so first we'll write what are the given thickness of the plate. It is given 3 mm. Okay, see what I will do, I convert into meter because this fluid pressure also in meter square and this modulus of elasticity also meter square. So if you convert into meter, that is a little bit easy. So I'll convert into meter. You can do in millimeter also, no problem. Okay, the thickness of the plate is equal to 3 mm. So 3 into 10 raised to minus 3 meter. Convert millimeter into meter, that is 10 raised to minus 3. And the length of the drum, that is what is the length? The length is given here, that is internal length and diameter is 50 centimeter. So it is 50 centimeter. So convert into meter divided by 100. So that is 0.5 meter. And diameter of the vessel, that is 25 centimeter. So centimeter convert into meter divided by 100. So 0.25 meter. Then internal pressure is given 3 meganewton per meter square. Meganewton is 10 raised to 6. So 3 into 10 raised to 6 Newton per meter square. Then modulus of elasticity 200 giganewton. Giga is 10 raised to 9. So 200 into 10 raised to 9 Newton per meter square. And Poisson's ratio is mu or 1 by is equal to 0.25. So what we'll do, first we will calculate circumferential stress. What is circumferential stress? It is given by sigma c is equal to PD divided by 2T. Okay, substitute P. P is equal to 3 into 10 raised to 6 and D is equal to diameter, that is 0.25, or here it is written 25 into 10 raised to minus 2. You can directly substitute 0.25 divided by 2 into thickness. Thickness is 3 into 10 raised to minus 3. Okay, if you substitute, you get sigma c is equal to 125 into 10 raised to 6 Newton per meter square you will get. You can convert into meganewton. So 125 meganewton per meter square. Okay, this is circumferential stress. Then calculate longitudinal stress. How you can calculate longitudinal stress? Sigma L is equal to PD divided by 4T. Substitute P is given, that is 3 into 10 raised to 6 and D is diameter 0.25 and divided by 4 into T, thickness 3 into 10 raised to minus 3. So if you substitute, you get sigma L is equal to 62.5 into 10 raised to 6 Newton per meter square. You convert 10 raised to 6 is nothing but meganewton. So 62.5 meganewton per meter square. So like this you can calculate what is circumferential stress and what is longitudinal stress. Then you have to calculate what is the change in the length, diameter and volume of the vessel. How you can calculate? You can use the formula directly. What I have solved the last class, some problems I have solved using the direct formula, but now I am using the other formula to find changes in the length, diameter and volume. What is that formula? We know that strain, this is circumferential strain. Circumferential strain is equal to sigma c circumferential stress divided by E minus sigma L divided divided by M into E. Means direct stress minus lateral stress. Okay. So not stress, strain. So this is circumferential strain, sigma divided by E. So sigma C divided by E minus Poisson's ratio, that is 1 by M into sigma L divided by E, that is circumferential strain. So if you know sigma C, that is you have shown here in the first calculation, sigma C is equal to 125. So substitute that 125 into 10 raised to 6 divided by E. E also given, so you can here then substitute sigma L, that is 62.5 into 10 raised to 6 into 1 by M. Okay, that is 0.3 here. Yeah. It is 0.25, not 0.3. Okay, so that is by mistake I have written. Okay, 0.3. Then 10 raised to, you can take E outside. So what is that? E is equal to 200 into 10 raised to 9, and this 10 raised to 6 you can keep it outside. So then 125 minus 62.5 into 0.3 is equal to, you get what is the circumferential strain. Okay, once if you know that, you know circumferential strain is equal to change in the diameter divided by original diameter. So change in the diameter is equal to sigma C into D. So D is given, that is 25. T is 25 centimeter. Okay, it is in centimeters. Also, if you substitute that, you get 0.01328 centimeters. Okay, next you can calculate what is this longitudinal strain, that is sigma L divided by E minus sigma C divided by M into E. Here this is longitudinal strain, therefore longitudinal stress divided by E minus sigma C divided, Poisson's ratio into sigma C divided by E. So substitute, you get longitudinal strain is equal to 0.000125. So change in the length, that is change in the length means longitudinal strain is equal to change in the length divided by original length. So change in the length is given by EL into L. I think you know this, right? Here, suppose how you get this, because this is longitudinal strain, that is equal to change in the length divided by original length. We want this, so delta L is equal to this E into L into L. That's why it is written here. And similarly here, delta C, why it is, that is circumferential strain, that is with respect to diameter. So change in the diameter divided by original diameter. We want this change in the diameter, that is circumferential strain into this D. Okay, that's why it is like this. Okay, now substitute, you get the answer, that is 0.00625 centimeter. Next, volumetric strain, directly you can calculate, that is volumetric strain is equal to EL plus 2 times of circumferential strain. So you know longitudinal strain, that is longitudinal strain is equal to 0.000125 here, longitudinal strain. Here, this is longitudinal strain, that is 0.00125 plus 2 times of circumferential strain, that is this one. Okay, and here and this. So into 2 times of this. Then we want change in the volume. Again, you can write the same formula, that is volumetric strain is equal to change in the volume divided by original volume. So change in the volume is equal to EV into V. So that's why it is written here. Substitute what is EV, that is 0.001874 into V. V is pi divided by 4 into D square into L. So D is 25. This is in centimeters only. Okay. So answer also in centimeters. 25 square into 5. 50. So you get 29.15. So like this, you can calculate what is circumferential stress, what is longitudinal stress, what is circumferential stress, what is longitudinal stress, and what is change in the diameter, change in the length, and change in the volume. Okay, here just a small change I will do. This is not 0.25. Okay, this is 0.3. Poisson's ratio is 0.3. So you will get this answer. I hope all of you understood. Thank you.